Welcome to lecture 7 part 2. Here we will discuss about couple of example. So this is pretty interesting example. What it says, assume that the mod 8 counter is in the 101 state. What will be the state after 13 pulses have been applied? Okay, so there are a couple of things you need to understand before solving this problem. It says mod 8 counter. So how many state it will have? So you already know mod number is equal to the state number, so it will have 8 state obviously. And later on it says your counter is on 101 state. So it says what will be the state after 13 pulses. So if it has 8 state, so after 8 cycle it will be at the same state, right? If you start from 101, after 8 state it will be again 101, right? And you need to determine after 13 what will be the state. So for that you need to draw the signal flow graph first. Okay, so mod 8, that means 3-bit counter. So 3-bit counter will count 0 to 7. So you draw the signal flow graph 0 0 0 0 0 1 up to 1 1 1 again 0 0 0. Okay, so it says 101. You are at 101. So if you start from 101 and after first clock 110, second clock 111, third clock 0 0 0, fourth, fifth, sixth, 7, 8. So after 8 it you will return to 101 again because it's mod 8 counter. So you will be returning at the same state after mod number, right? But it says after 13 pulses. So 8 pulses you return to the same state where from where you started. This is 9, 10, 11, 12, 13. So after 13 pulses you will be at 0 1 0, right? So I think it is pretty clear now. Okay, so if so, then I'll give you one task now, so you need to draw it by yourself. Okay, let's move to the next slide. So actually here this is the solution what we already discussed. So for mod 8 counter it is 101 state. What will be the state after 13? So it describes how you can write the solution as well, right? So you need to draw the signal flow graph obviously, and you need to write it. So after 101, so you will be back to 101 after 8 state change, right? And if you move to another 5, then it will end up with 0 1 0, which is after 13. Okay, so notice that because it is mod 8 counter with 8 state, it take 8 state transition to make one complete excursion around the diagram back to starting state. Yeah, so it will be after the mod number, right? You'll get the starting state. This concept is very important and it will be needed for the next problem as well. Okay, so this is your class task now. So if you know the concept from the previous problem, I believe you can solve it very quickly. Let's try. Okay, so assume that the mod 16 counter is in the 101 state. What will be the state after 20 pulse have been applied? So first of all, I'm giving you some hints actually. So you have 16 counter, I mean mod 16 counter. That means you will have 16 state, right? So if you start from 101, so you will be returning to 101 after how many state? That's the first thing you need to determine. And from there you need to move to 20, okay, pulses. So if you move to 20 pulses, then what would be the pulses? It's pretty simple, I think. So I suggest you try to draw the signal flow graph for mod 16 counter, then it will be pretty easy to find the state after 20 pulses. If you can't solve it, we'll discuss in the lecture, so I suggest you follow the live session. Thank you. So here is another important example. So what it says, let me use the laser pointer first. Consider a counter circuit that counts as 6 flip-flop wired in the arrangement of Q0 to Q5. So 6 flip-flop, that means determine the counter mode number. So you know number of mode number is number of states. So you need to determine number of state. So for 6 flip-flop you will have 2 to the power n, I mean 2 to the power 6 state. So that will be your mode number, right? Determine the frequency at the output of the last flip-flop Q5. So frequency when the input frequency is 1. So frequency of this flip-flop will be the input frequency divided by mode number, if you remember from the previous slide. Now what is the range of counting? So you know how we can determine the range of counting. It is 2 to the power n minus 1, right? And also it says we started from 60 state. What will be the state after 129 pulse? This kind of things you already done it in the last problem, so I think you will be able to solve it. Okay, so still if you can't find it, move to the next slide. I'm explaining there how you can solve it. Okay, so mode number. So you know 2 to the power number of flip-flop 64. So the frequency at the last flip-flop will be equal the input frequency divided by mode number. So your input frequency is 1 and number of mode number is 64. So it becomes 15.625 kilohertz. So it will count, as we said, 0 to the power n minus 1. To the power n minus 1 is 63. So 0 to 63. Or in terms of binary, you can write it 60 or 61. So the number of state is same as the mode number. So because this is a mod 64 counter, so every 64 clock pulse will bring the counter back to its starting state, right? Say start from 60, after 64 state you will be back again 60. If you double it, that means after 128 state it will be back to you 60. So it suggests to find the state after 129. So it will be just the next state of 60 state. This is 501 state, right? This is the state of after 129 pulses. Okay, so if this concept is clear, so I'll give you one more class task. I suggest you try to solve it by yourself. Okay, if you can't find, then you should follow the lab lecture. This is the class task. Consider a counter circuit that contains a 8 flip-flop Q0 to Q7. So you've given the 8 flip-flop. So that means mod number is 2 to the power 8. Determine the frequency of the last flip-flop. Okay, so you have given the input frequency. So it will be input frequency divided by mod number, right? The range of counting 0 to 2 to the power n minus 1. Here your n is 8 flip-flop, right? 2 to the power 8 minus 1. Okay, so it says starting is 80, counter state after 258 state. So 2 to the power 8 means how much you need to determine. So if you start from 80, so after 2 to the power 8 it will be returning to this 80. So, but you need to determine 258. So that's why you need to know how far you need to go from here. Okay, so I believe you can solve it by yourself. Anyway, so if you find any difficulty to solve this one, I suggest you attend the live session or view the recorded video, then you can solve it. Thank you.